Hey, geometry students, Mr. Zacek here, back and better than ever. Now, for this lesson in your notes, you're going to kind of have to turn the page a little bit. And we're looking at proof terminology, and we're going to look today at how we mark pictures, and then each of these kind of rows is going to be a tool that we could use to combine together to create different proofs. And so this is going to be a this is very important, okay? And something that we're going to do a lot of. So like the homework tonight is going to be the exact same thing that we do on this notes, or not the homework, but the assignment. You're going to have a quiz that is going to be exactly the same as this because it is very important. Okay, so first thing up is perpendicular. So if we have in some kind of question where we're trying to create some conclusions, we've got DB here is perpendicular to AC. See our given there. Now the way we're going to mark that on our diagram is we're going to mark it with right angles. And very often we can name these angles. Just going to make my pen a little smaller. We can name these angles with those numbers, or we can put with the letters, or we can put numbers in there. So I'm going to call those angle 1 and angle 2. So now here's what we do. In our statement, DB is perpendicular to AC. We know that is because it's given. And here's what we're going to say first. The next statement is angle 1, okay, and angle 2 are right angles. And here's the reason. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. All right, so we were given that they're perpendicular, and that's kind of the definition of perpendicular. The next statement that we can make is that angle 1 is congruent to angle 2, and the reason is all right angles are congruent. All right, so there's one proof part. The next one that we have as we work our way down, vertical angles. So we're given that AD intersects BE. Now over here we can call this angle, these are vertical angles, or these up here are also vertical angles. So we can use either one of those. Now you see this in the statement here, and you see in parentheses where we've written that this is a freebie. And what we mean by that is you don't have to have it written actually that those are they intersect. A lot of times it will say that, but whenever we see that, just see intersecting lines, we can think vertical angles. So here's what we could say. We could say angle ACB is congruent to angle ECD, or we could say angle ACE is congruent to angle BCD. Those are the two markings, right? And the reason is if two lines intersect, then they form congruent vertical angles. And I say it like this. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. If two lines intersect, then they form congruent vertical angles. Blossom of snow, may you bloom. Oh, that's Sound of Music. That's where that came from. All right, so little ditties, just because those ones are kind of popular and they show up a lot. And again, if you wanted to go back here with the vertical angles, we could number those angles. As long as you write the number on the diagram, you're good to go. All right. Next up is our segment bisector. Now, people make a lot of mistakes with bisectors. They put them in, they just, you have to understand what is doing the cutting and what is being cut. So CD is bisecting AB. That means AB is the segment that is being cut into two equal parts. So AB would be AE and EB. Now we don't know if it works the other way around because we're not told. We're not told that AB is bisecting CD, so we can't make that other conclusion there. So what we write out our given, we could say AE is congruent to EB. And here's what the reason is, that if a segment bisects a segment, then it divides it into two congruent segments. You could say cuts, all right? So if a segment bisects a segment, then it divides it into two congruent segments. Really what we're writing there, and the reason is we're writing the definition. And what's this, so you're always going to see the statement is going to be specific to the problem. The reasons are going to be general. All right, midpoint. Given D is the midpoint of AB. Well, midpoint is the middle point, so it's going to divide it into two congruent segments. So what we would write here in our reason is, we could say, our statement would be AD is congruent to DB. And we know that because if a point is a midpoint, and in this case we know that D is the midpoint of AB, then it divides a segment into two congruent segments. So let me see if I can fit that in there. Okay, so then it divides a segment into two congruent segments. Squeezing it in there. All right. So that's always going to be the reason we use if we have a midpoint. All right, next up is an angle bisector. Now, here's where people start to make the mistake. The ray, okay, so this is a ray, is bisecting an angle. So now, if I cut an angle, I'm going to create two congruent angles. So I want you to see the difference between the segment bisector and the angle bisector. They both have a ray or a segment at the beginning, but it's what is being cut. Up here, the segment bisector, AB is the thing that is being cut. Down here, the angle is what's being cut. So as a result of that, we're going to create two angles. So that would be angle BAD congruent to angle CAD. And the reason is, if a ray bisects an angle, so if a ray bisects an angle, and that could be a segment, it doesn't have to be a ray. If a ray bisects an angle, then it divides it into two congruent angles. All right, so I spend a little more time talking about that one because it's really common that people confuse segment bisector and angle bisector. So we have to understand what is being cut. In the segment, it's a segment that's being cut. Here it's an angle. So if I cut a segment, I get two congruent segments. If I cut an angle, I get two congruent angles. Okay. All right, next up we have median. Okay, now when we get here, here's where we're going to start using some words. Median and altitude, we might not be as familiar with the definitions of these. Okay, so a median, when I think of median, I think of M and M, because a median is drawn to the midpoint. So what we're going to find here is C is the midpoint. Well, we know the midpoint then divides the segment into two congruent segments. So we have a kind of a two-step process here, and the first is to say that C is the midpoint of BD. And now we're going to write out the definition of a median. Okay, so if a segment is a median, then it is drawn from a vertex, from a vertex to the midpoint of the opposite side. Okay, so of the opposite side. If a segment is a median, then it is drawn from a vertex to the midpoint of the opposite side. And that's why with median, I write M&M, because I want to think median goes to the midpoint. Now, we've already done the midpoint, so we know that as a result of C being the midpoint, we can say that BC is congruent to CD. And you could just flip your paper over and copy the reason that we wrote down for midpoint, which is if a point is a midpoint, then it divides a segment. Okay, so then it divides a segment into two congruent segments. Divides a segment into two congruent segments. All right, so that's a median. Median to the midpoint. Altitude, over here we're given that AC as an altitude. So when we think about altitude, altitude is height, and height is always measured perpendicular to the ground. So I'm going to call this angle 1 and angle 2. All right, so, and those are going to form right angles. So here's the progression that we will follow with this. So we're going to say that AC is perpendicular to BD, and here's the reason. If a segment is an altitude, which we were given, so if a segment is an altitude, then it is drawn from a vertex perpendicular to the opposite side. So then it is drawn from a vertex perpendicular to the opposite side. So that's the definition of an altitude, is it's from the vertex is A, and then it comes down perpendicular to the opposite side. Now, really, it's not new. It's actually, we're going back to the first one, which was about perpendicular. So we say that angle 1 and angle 2 are right angles. Okay, and then there's that little ditty. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Okay, so right angles, and then we said next that angle 1 is congruent to angle 2, and the reason is all right angles are congruent. Okay, our next one is parallel lines. And so we have parallel lines here, and we have a couple options here. Let's start off here. Basically what's going to happen is angle 1 is congruent to angle 2 in all of these cases. So angle 1 is congruent to angle 2, angle 1 is congruent to angle 2, angle 1 is congruent to angle 2. It can show up looking like that. All right, so what's the reason? Well, we know the parallel that was given. And you have two reasons. So one of the reasons is if two lines are parallel and cut by a transversal, then they form congruent corresponding angles. We're going to spend more time a little bit later talking about parallel lines. So we'll get into that a lot more. So one pair is corresponding. So this one up here, those are the corresponding angles. And again, we're going to go into more depth in this a little bit later in the year, so I'm not going to spend a ton of time with it now. The other one are called alternate interior. So same start, if two lines are parallel and cut by a transversal, then they form congruent alternate interior angles. Congruent alternate interior angles. Okay, so these ones are the alternate interior angles ones. All right. So we have the freebie that we had up in there before was vertical angles. The other freebie is when a side or an angle are the same. Okay, so then we use the reflexive property, and we'll get more into that when we do some more examples, but just good to have it on our sheet for now as we do that. Okay, so this lesson is so key, and it's really what we have to work on is just learning these, really their definitions and understanding the order of how things are going to flow. This, if you learn this, it's going to make things go so much easier for the proof parts. Okay, so it takes some time. We're going to have a quiz. The quiz is exactly like this, but you got to do a little bit of work here in learning these definitions in order to do that. All right, so your homework assignment, or not your homework, your assignment related to this is simply to do this again on another sheet of paper, because we just have to know it, and then your quiz is going to be the exact same thing. So really studying so you do well on this quiz is super important. All right, good luck. Thanks.